Hi, I'm Gerardo from AWS.
Hi, I'm Ross Ashworth from TP-ICAP, and this is my architecture.
Ross, thank you for sharing this architecture. I can see that you built something with Bedrock at the heart, so I'm curious to hear what business problem are you solving with it?
Yeah, so TP-ICAP is a large interdealer broker with a lot of IT. It's very tech-focused, and this tool is a tool to help our IT staff.
Okay, perfect. So let's dive in. How does it work?
So we have a simple UI created in Amplify that our users can interface with, and they can ask questions about the infrastructure that we host. And when they do that, a WebSocket connection is made via API gateway. Web.
Interesting. So why did you choose a WebSocket?
It needed to be a bi-directional flow in communication.
Okay. Yeah. And so you open the socket, and then how long does it take for the answer to come back?
It comes back very quickly, yeah.
Okay, perfect. So when the question is in, what happens next?
Yeah, so the connection is made to API gateway, which then hands off to a connection manager in Lambda. Lambda then uses DynamoDB as its cache, so it stores the connection information in DynamoDB, and then sends a message to an SQS queue. That is then processed by our agent executor in Lambda.
Great. So you're routing the message in this Lambda function, then it gets scheduled for processing in this second part. How do you process it? What happens there?
So this Lambda function is our agent executor, and it's actually running as an autonomous agent, and it knows that it can speak to Amazon Bedrock to get a fully hosted LLM from Bedrock, and using that LLM, it will then in its chain of thought know to go to our external sources, which are either Lambda functions that talk to Amazon Aurora or open search knowledge bases that contain information about our schema.
Great. So the LLMs, I presume, are being used to construct a response for the support stuff?
That's right.
And it's leveraging your existing data.
That's right.
So what is this data?
So it's complicated data from multiple data sources in our RDS database. So that includes AWS config and AWS SSM, but also stuff outside of AWS like VMware and network discovery tools.
Okay, so you're consolidating all that into this one relational database.
That's correct, yes.
And so why did you build the OpenSearch part then?
So this is like a text-to-SQL implementation, and this understands our schema. So in our knowledge base, we've put in a vector database within OpenSearch the schema of all those tables, and the agent will go and get the speak to the knowledge base and get the SQL query back that needs to be run to return the data. And then that SQL query is also run by the same Lambda job and written to S3.
So you're basically using, you build RAG functionality to make it easier for the model to leverage your data?
That's exactly right.
In a simple and faster way, I presume?
Yes.
Perfect, perfect. And so what happens next? Answer is constructed?
Yep, so then it goes back from the agent job to the outgoing SQS queue, and then back to the connector Lambda job, and then eventually back via API gateway to the users.
Perfect.
In the UI. Yeah.
Perfect. Is that the only way the users interact with the system, with the web UI?
Actually, no, we now have an MS Teams connector.
Okay.
So you can call a chatbot within Teams and ask the same questions and get the same answers.
Brilliant. So so you mentioned knowledge bases for Bedrock. Any other Bedrock features that you're using?
Yeah, so we've been using the model evaluation to test the results, and also guardrails within Bedrock.
Great. What model did you choose?
With the Claude 3.5 latest release.
Awesome.
Yeah.
It's pretty good, isn't it?
Yeah, we've definitely got the good results from that. Yeah.
Great. So Ross, thank you so much. I love how you're using generative AI in order to improve the productivity and the experience of your support staff. Thank you for sharing this.